Good morning all of you. So we'll be studying in this tutorial about the ROS. So what is ROS, right? So ROS is now the industry standard in the robotics, right? So ROS stands for Robot Operating System. A robot operating system. So it stands for robot operating system, but it isn't actually operating system. It's a operating system running on operating system, you can say, or a pseudo operating system, you can say, right? So what ROS does is to simplify the things of connecting the components of the robots each other so that they can talk to each other, and it presents to us some modules that are extremely useful. So we'll be studying them in length from A to Z, right? So let's get started. So what is actually ROS and how does it work? So the main component of ROS starts with the ROS master. So what is ROS master and how does ROS work? So you can say that imagine a robot. So just imagine a robot. So I am not very good at drawing. You can say this is your robot, this is your camera, right? And these are your wheel encoders, and there are some ultrasonic sensors here. So a lot of things, right? So this is your, let's say, ROV. So it consists of a lot of sensors and a lot of data is coming into the microprocessor unit, which is, let's say, here, which is the brain of your robot. So what is happening is these data are the nodes. Each sensor, each data from the sensor is a node in ROS, and these nodes are then under the ROS master. So ROS master helps in identifying these nodes and keeping a track of these nodes and helping the nodes in communicating with each other. So the main use of ROS is like that. If you have ever used in the electronics, you have something like this called a breadboard, right? So what happens in the breadboard is that when you attach a wire, let's say here, which is of plus 5 volts, or let's say any stream of data is flowing through here. So internally these are connected so that if you read from this or this or this or this, you will get the value whatever the data is being sent here. So this concept of putting the data into something connected is called publishing, and this method of reading the data is called subscribing. It is called subscribing, and this of putting or publishing the data is called publishing, right? So as I was talking about this robot, so there are a number of data points, like you can say, let me change the color. So you can say there is wheel encoder node. Wheel encoder node, right? This is one node. You have the camera data node. This is another node. you have, let's say, ultrasonic sensor node. This is another node. So there are a lot of nodes, right? So these nodes are under the ROS master. So a ROS master knows everything about how many nodes are there and how many nodes are being are subscribing and publishing, right? And these nodes can exchange the messages via publishing and subscribing. Messages and messages, right? So it can be, as I said, in this robot, what is happening is the camera node is publishing all the images, all the frames that it's capturing into the node, and then it's publishing all this data to every node. Any node can now subscribe to that data. So how can it be useful to us is that you don't have to explicitly connect each and every sensor to its functionality. What you can do is just as it's capturing the images, right, or it's all the wheel encoded data is capturing the data, so anybody who wants to read that data can just subscribe to that and can just read through the data. You don't have to connect these explicitly. So this is the convenience that the ROS gives us. And now, as I said, ROS is currently the industry standard, and we'll try to study each and every component of it. Thank you.